Okay, are we ready to go? Okay. Hey, good afternoon, everyone. I know it's late, but welcome to the session on deep dive for the working group, multi-tenancy working group. I'm Sanjeev from Cisco. This is Adrian. Go ahead, Adrian.
I'm Adrian from Google up in Waterloo.
And we've got several folks who are active in the working group, in particular Ryan Bezdicek. Jim Bagwadia has been recently getting engaged quite a bit, and then several folks around. So what we want to do here is that, although this is a deep dive, we know that a lot of people may not be familiar with this working group, so we want to make this match your expectations. So we've got three kinds of content here. We've got some slides. I'm going to put those slides in the session, which I haven't had to done it yet, but I'll add those slides. So we were thinking, just 5-10 minutes of slides just to catch up some folks that might be not familiar with what are the projects and sort of a little bit more detail. We've got a couple of demos, maybe each 5 minutes, and then so we could do about 15 minutes of Q&A after that. Does that make sense? Would you like more of one or the other? No slides at all, just Q&A and just demos? We can do whatever. So let me ask by raise of hands, how many would like some introduction to the working group and some slides? Okay, quite a few seem to want that, so we'll do.
Called that unanimous, basically.
We'll do that we'll do it short because we have other YouTube recordings and other material, right? And then how many want to see demos? We've got 2 demos of 5 minutes each. Okay, everybody wants to see demos as well. So we'll do, we'll do 10 minutes of slides, 10 minutes of demos, and 10 odd minutes of Q&A. Okay, let's go with that. Okay, so there's a lot of all our contact information is here. You can Google for us, and you can reach out on all these links. So this is the community, right? So we've got 3 or 4 major projects going on. These are the names of the folks that are driving a lot of the projects. Adrian right here is driving the HNC work, for example. Faye, who's I think not here today. Faye, if you're here, please raise your hand. He may not be here. He's driving virtual clusters and tenant controller. Jim right here is kicking off the multi-tenancy benchmarks. Ryan is doing everything. And then many of you are contributing, so we really appreciate that. And we want to hope to continue this work, growing this working group, right? So hopefully we can tell you enough about it that will get you excited to contribute in whatever way you feel like you can. So I'm going to skip over what Kubernetes multi-tenancy is. This hopefully audience knows what it is about. I'll just mention very briefly, since we're just doing 10 minutes of slides, what are the tracks that we are trying to follow and how we plan to evolve this working group, right? So first we decided to say that this is a nebulous space. People haven't quite defined it right. So what are the different models of multi-tenancy that are possible, and what do we want to address in this working group, right? So very, very briefly, model A is multiple clusters, multiple Kubernetes clusters on an IaaS. Model B is namespace grouping, creating new tenant CRDs that own Kubernetes resources like namespaces. Model C is virtual clusters. And Model D is sort of a theoretical possibility where we go back and rewrite core Kubernetes to make tenancy a first-class citizen within Kubernetes. I know I'm going through fast, but since we agreed that we're just doing 10 minutes of slides, bear with us if some of this is not familiar with you, to you, right? But feel free to ask questions. We'll just do 10 minutes of slides, no more. I'll have the slides on the website for you to look at in more detail. Okay, briefly about the tenant operator model, right? So in this project, a series of custom resources are being defined that will allow someone to self-service create tenants in a Kubernetes cluster and define a set of namespaces that are owned by that tenant, okay? This is sort of the high-level architectural model from Faye. And you can see that there's a tenant CR that creates a number of resources in what is called a tenant admin namespace. So there's an admin namespace per tenant instance. And in that namespace, control resources specific to that tenant are maintained. So you can see there's another row of CRs. They're called tenant namespace CRs, right? These are CRs that control actual user level namespaces, okay? And you can also see the virtual cluster CR because the goal there is to have the concept of a tenant which owns X number of namespaces and possibly Y number of virtual clusters. So a tenant owns certain number of namespaces and certain number of virtual clusters. That's the goal there, right? And you can see sort of the logical layout here. Okay, let's keep moving. That'll just be adequate for a very brief introduction. And this is the kind of YAML that, that Faye and the team have proposed, where you create tenant CRs, you specify the tenant admin namespace. The required namespace prefix is true is an interesting thing. As you know, in a single Kubernetes cluster, namespace have to be globally unique, right? So how do you create multi-tenancy where tenants may want to create their own names for namespaces? So one way to do it is to enforce that they make their namespaces unique to begin with, and you reject any duplicate namespaces. The other one is to actually prefix a tenant name in front of the namespace. But really, the right solution for that is the virtual cluster solution, which is the other thread, right? So this is the model B for tenant operator, right? A sample of it. And we have a demo for this. Hopefully, we'll be able to do a quick 5-minute demo on this. The next thing is hierarchical namespace controller. So Adrian, you want to very briefly summarize that for now, please?
Sure. The idea behind hierarchical namespaces is that, so it's not nested namespaces. It's not a way of getting sort of more uniqueified namespaces for free. It's really about a couple things. It's about policy enforcement. It is about self-service namespace creation. And it's about some kind of concept of standardizing an idea of hierarchy inside Kubernetes. So what you can see here is that we've set up a couple of different namespaces to represent different parts of an organization. So we've got a root namespace called the organization namespace, and then we've got a team namespace, and then 2 services owned by that team. And in the org namespace, we've created 2 policies. One is the RBAC policy for our site reliability engineers, and another one is the global network policy that needs to be applied in every namespace that belongs to that org. And then what we did with the team namespace is that we set up the hierarchical config, which is a custom resource, to point to the parent. And you can see in yellow, those policy objects got propagated down. And we also added some new ones, which are here our back policies for the developers, and let's say some secrets that all of the services in that team need to operate. And then you can create the service namespaces for additional isolation underneath that, and all the objects get propagated down. One of the nice things about HNC is that you don't need to have cluster level permissions to create these namespaces. You just need to have permission to edit the hierarchical config in the namespace above it, and then you can ask for a namespace to be created, and I'll give a demo of that in a minute.
And this is a brief summary, again, on behalf of Faye, of the direction for the virtual clusters solution. So the difference between the model B, so I mentioned model B and C, right? Both the tenant operator and the hierarchical namespace solution are for model B, where you're essentially leveraging namespaces within a single cluster as representing a tenant, right? So the key point is that in both of these solutions, tenants cannot request cluster scope resources because tenants are essentially bound to a set of namespaces. In many enterprises, that's seen as a constraint because some tenants want to define their own CRDs, for example, or other cluster scope resources. And you can't really have 2 different tenants request the same CRD definition. So that's where Model C comes in. Model C actually gives separate API servers, so tenants can actually define their own cluster scope resources as well, right? So Faye and Harry from Alibaba. Is anyone from Alibaba here? For Harry, maybe? Okay, so those folks are actually doing some real work. So those guys have put out a video now, which we will be putting on our YouTube playlist. And there'll be a lot more coming on that project. And I'm sure that they would welcome a lot of input and contribution from the community on that one in particular. And the other thing is that this is, again, a slide from Faye, but what he's saying is that a way to unify all these threads of work in our working group is to look at the concept of a tenant. And as we said earlier, it can create it can instantiate a tenant operator. That's the logical representation of a tenant. It can own a collection of namespaces. Some of those namespaces could actually be roots of namespace hierarchies, leveraging the HNC work that Adrian and team are doing. And some of those instances could be virtual clusters. So this is sort of the unified view of how all these three tracks of work could potentially be combined into a single architecture. So this is sort of a long-term view. Right now, each of these tracks will proceed independently, and then we'll talk about how or not to show some combinations of these projects. So that's kind of the long-term view. Okay. Another thing that we kicked off recently is, coming back to the data plane for multi-tenancy, and in particular, benchmarking, right? So, so Jim and a team here have recently been contributing in areas related to benchmarking. And the thought there is that let's define, somewhat similar to CIS benchmarks, a set of benchmark tests which you can run on a cluster and get a quantitative representation of whether you meet the criteria that the community decides is appropriate for defining it as a multi-tenancy ready cluster. So there are different dimensions to this. There are categories of tests related to, for example, control plane isolation, tenant isolation. Actually, maybe Jim, you want to briefly chime in there and summarize there?
Thanks, Sanjeev. Yeah, so like Sanjeev was mentioning, some of the other constructs that we've been working on talk about how to achieve multi-tenancy, right? But with the benchmarks, what we're doing is we want to be able to measure the desired state independently of how multi-tenancy is configured. So you may even manually use namespaces, other constructs, and configure your cluster, which is fine. But how do you prove that you've achieved some level of multi-tenancy within the cluster? So that's where we have 3 levels defined, which were on the previous slide. Level 1 would be independently of any controller, any CRD or add-on you put to your cluster, is your namespace and the constructs around the namespace, like network policies, other security context policies, things like that, are they properly configured? And we would do behavioral as well as configuration tests to prove that they are properly configured, much like if you're familiar with the end-to-end tests, which are part of the conformance, the API conformance test suite as well, right? So that's the idea with level 1. Level 2 is to allow self-service DevOps too. So their teams should be able to create their own namespaces, and along with the namespaces, maybe even request like different quota levels, things to that nature. So that would be level 2 is what we've defined. And level 3 would be what Sanjeev mentioned, where the Alibaba team has been working with virtual clusters to actually virtualize the control plane to get your own API server. You can install your own CRDs, et cetera, right? So, and these are still proposals, so there's things to be reviewed and refined there. There was a good discussion earlier about, maybe adding in even security, like using gvisor and other things at different levels to add more security and context. And then with the tests, we have, like you see over here, there's different categories that we'll test for. And this will also be expanded over time as we proceed. So certainly in terms of contributions, we're looking for both in helping define these categories and tests, as well as we want to create a tool in parallel which will do the end-to-end validation. So this is written in Go. It's very similar to if you're familiar with Sonaboy and the conformance test tool. These are simple test tools which use Ginkgo and other frameworks to validate either a configuration or a particular behavior in your cluster.
Thanks, Jim. And I've got some more information on the slides, so let's skip over all of this, and perhaps we should move on to demos now. So hopefully that gave you all who may not be familiar with the working group completely, a very, very quick picture of what's going on, feel free to reach out to us either during the Q&A or after the session for more details. So now, Adrian is going to give a quick demo on hierarchical namespace controller.
Is this relatively legible? Okay, good. So I'm just going to give a very quick demo showing exactly what I was describing on the slide. So you can create a namespace that represents your organization. And pardon me, nobody can type during demo, so I'm cheating. And so what I've done here is I've created a couple of namespaces using my cluster admin level privileges right now that shows all of the different aspects of the organization that I want to create. It's got a team, that team owns a service, and I can create, for example, roles for the team A SRE and some role bindings. And here I'm going to create some RBAC roles for the organization level SREs. And so I've now created these, but if you go look inside the service itself, you will see, oops, absolutely nothing, because they haven't been hooked up yet. There is no relationship between these namespaces just yet. And so what I'm going to do is start out by running this new kubectl HNC command, which is just a plugin for kubectl. And I said that the parent of team A is Acme org. And then I'm going to do the same thing for service 1 and Acme org, except I had a typo. Instead of saying that, instead of setting the parent of service, I said that the parent of Acme org is team A, and it rejected that because you can't have a cycle in your hierarchy. So it does have certain features to stop you from shooting yourself in the foot. And so if we now correct that, we can see very quickly with the tree command that we have set up the hierarchy the way we expected it to be. And while before, when I had a look inside of service 1, there were no resources, or sorry, no roles. If we look now, we can see that, as expected, service 1 has org SRE, which claims that it was inherited from Acme org, and it also has team A SRE, which was inherited from team A. And in this demo, by the way, this demo is public, you can go follow along yourself. There are all kinds of things that you can do to modify the hierarchy, and you will see that these objects get deleted if they're supposed to be deleted. So if you change the parent of one namespace to another one, if you update them, they will get updated. And it doesn't just work with RBAC rules, it also works with a variety of other objects. Right now, that set of objects is hard-coded, but it will be configurable at some point. This is using version 0.1 of the HNC, and by the way, do not attempt to use this in prod. This is an initial experimental release that we want to put out there to get some feedback. The other thing that I mentioned was the ability to do self-service namespaces. And so here, what I'm going to say is that Acme org, our top level namespace, has a required child of team B. Now, I didn't create the namespace called team B, and that's all a feature of the controller as well. If you go look now at Acme org, you will see that team B has been created as well. And if we check out the resources inside team B, you'll see that it has the org SRE, which is the only default role that I've defined. And so that's basically it, and so far it scales relatively, I mean, the interface, I should say, scales relatively well. I've been setting up some fun little hierarchies across my, my cluster here. You can see that it's not really, there is no single root. You can have as many roots as you like. Any existing namespace just gets to sit there, and it's only when you start using these controls that we create that CR and things start pointing to each other. That's it. There are other things to show, but I think that in the interest of time, we can move on.
So we are tracking just about right. So we could do one more demo, or we could do straight to Q&A. Any preferences? One more demo? Hands for one more demo? Okay. So we'll do that in 5 minutes, and then we'll have about 10 plus minutes for Q&A. So this demo is for the tenant operator work, right? So just as a refresher, a set of CRs that you use to represent tenants And then these tenants own cluster resources like namespaces. So end-to-end mapping of namespaces to tenants. So I've actually got a little auto scripting thing, which is, okay. So first we look at the cluster, we see, okay, there's a couple of new CRs down there. You see tenant namespaces and tenants, right? So this cluster is ready to take those new CRs. Also, we take a look at the CNI. So I'm actually having a little bit of the data plane isolation as well in this demo. It so happens we're using Calico as a CNI, right? So we'll show, if we have time, we'll show an illustration of combination of the control plane, the network policy, and the pod security policy for complete isolation. To represent tenant identities, for this demo, we're going to use service accounts. So 2 service accounts representing tenant 1 admin and tenant 2 admin. So we look at the sample YAML for creating a tenant. Very baseline version here, okay? So we're saying here, please create me an object called tenant. That shall be called tenant T1. That shall have all its admin stuff in this namespace called T1 admin space, and whose admins will be this service account, right? Any RBAC subject can be admins. The reason it is set up this way is, again, with the self-service in mind. Anybody belonging to an RBAC role called tenant creators will be able to create tenants. Once they create a tenant, only the admin specified inside the tenant manifest will get modify and delete permissions. That allows anybody to self-service create tenants, but nobody to step on each other's tenants. That's the sort of motivation there. Okay, and we go ahead and create that tenant, and it's been created. Now we also notice that a few access controls have been set up for us. In particular, some cluster roles for this tenant admin role. I'm not going to go into the details of that, but these essentially ensure all those properties I mentioned earlier. The appropriate privileges for the tenant admin, ensuring tenant admins do not get permission in other tenant spaces, and so on, right? So this operator takes care of provisioning all of that. And then role bindings within those target admin namespaces. So this is the only admin for that tenant in this example. Similarly, creating another tenant, right? Again, anybody belonging to the group tenant creators can be creating self-service tenants. Okay, similar to before, this time somebody's creating a kind tenant with a name tenant T2, and he's using his own admin space and his own admin. Let's go ahead and apply that. Okay, so now we see there's 2 tenants in the cluster. We talked about this concept of a tenant namespace, right, which is a resource through which a tenant admin creates namespaces. So you don't create namespaces like you do today with kubectl create namespace. This will be an operation performed on your behalf by the controller. Right? So this is saying, please create me an end user namespace called T1N1. Here, I have ensured that my naming is non-conflicting by calling the namespace T1N1, right? So that ensures I have prepended the tenant name. And similarly, another namespace. So now, using the kubeconfig of T1 admin 1, so me acting as T1 admin 1, I'm assigning those namespaces to that tenant. So this is tenant admin in action, grabbing cluster resources. Okay, that's been created. Similarly, tenant admin 1 in action, grabbing another resource, another namespace, and confirming that this is what tenant admin 1 owns for now. And the cluster admin looks at the global set of namespaces. He notices that there are 2 tenant admin namespaces, and then tenant 1 has actually created 2 user namespaces. Now, as the identity of tenant 2's admin, I try to see whether I can access tenant 1's resources, right? So this is me as tenant 2's admin trying to get information about tenant 1. Okay, that's blocked. So those automatic RBAC rules that we had set up using specific resource names are in action. Now, a little bit of a networking isolation demo. So we are now attaching labels to make sure that these labels indicate which, this will be useful in attaching the appropriate network policies to these namespaces. Okay? Eventually, we will also look at the, there's also namespace automation that you may be familiar with. So that can be integrated with the tenant operator as well. Okay, and this is an example of a Calico network policy. This is in particular a global network policy. One quick note here is that one thing to note, when you're trying to make a cluster multi-tenant and you want to have network isolation, you probably do not want to use standard Kubernetes network policy for that. You want to use standard Kubernetes network policy for the users, because that can be used for application level micro-segmentation, right? Instead, you use global network policy as a cluster admin's tool. So the cluster admin has a different type of resource for network policy, which he uses only for tenant isolation, and the developers have a different type of network policy resource, which they use only for application micro-segmentation, right? A lot of the current ad hoc solutions, they tend to overload Kubernetes network policies to do both tenant isolation and application isolation, which you really shouldn't, because then you have to give a developer some cluster admin-like privileges, and they could inadvertently break tenant isolation boundaries. Not sure if I explained that enough, given that we are rushing through this, but hopefully you get the point that you need to think about not just leveraging Kubernetes network policy for both tenant isolation and application micro-segmentation. So another thing is that this has got a part security policy, so it will not accept end-user containers that require privileges. So we are actually running a curated version of Nginx. So just as you perhaps may know, there are a few repositories which have curated versions of standard containers, like Bitnami Nginx is curated so that it doesn't actually require, it requires minimal host network privileges. So you want to be using those containers, and you want to have set up a part security policy that only allows those containers to run in your tenants. Okay, then you know what? Let's stop the demo here. So what we did was we basically told you some of the projects that are going on, had a quick demos. Let's open it up for Q&A. What's on your mind? How can the working group help?
The question was, the tenant CRD and the HNC seem similar, and how are they different? The difference is that the tenant CRD is a sort of end-to-end lifecycle flow, whereas the HNC is a building block. And so as you can see, HNC is expressed purely in forms of primitives you already know and hopefully love, and adds a relatively small set of extended behaviors onto them, whereas the tenant CRD is a whole model by which you can organize tenancy into in your cluster. And they are going to be building on one another, most likely.
Yeah, so you can use these independently, or you can use them in combination, is the goal. Yeah, hi. Yeah, so we will. Yeah, we definitely need to be preparing more documentation on how these things tie together, and we'll take an action item to do that. We also do not want to be too opinionated, because there are different ways of doing the same thing. So we want to give references, but say that this is just one way of doing it. But we do take the AI to prepare more.
I would add that not all the primitives are in place yet, and so that's some of what the work that we're doing is to put those primitives in place. Once we have the benchmarks in place that Jim and co are putting on, then we will be able to more easily write a best practices guide, which will basically say, if you look like this, do that. If you look like this, do this.
I mean, we could have documents on what you can do with Kubernetes today, which is a limited version of multi-tenancy. But we'll wait for these projects to mature further before we have a best practices involving these projects. But the action is we will produce more end-to-end documentation. Let me just pick, yeah, the gentleman over here.
Just wondering if you targeted milestones for like 6 months from now, maybe 1 year out, like where are you, like how fast do you see yourself moving?
Well, you know, let me have the other folks as well. I'll give you my interpretation, and then the other folks have an opinion as well. We are not limiting ourselves by timelines at this point. We want adequate functionality before we declare something as usable. So I think that we're looking at essentially, depending on the level of multi-tenancy, you know, Jim talked about various levels, right? So elementary solutions can actually be done today. But a lot of these projects, we're looking at essentially at the next 6 months for these to really mature.
Yeah, one other thing to add is, so initially we're focused on level 1, and the idea is to at least get agreement on the set of tests that we want to do, and then we'll go about automating those. So there is a document where we have been collecting different use cases. If you go to the multi-tenancy repo, you will see the different use cases and suggestions we've collected. So certainly contribute your use cases, because that will influence the benchmarks and what we target in what order. And you can, of course, in any one of our meetings, if you come in and give us some of the feedback, things that you're seeing and how you would like multi-tenancy to be measured, that would be helpful as well.
Yeah, come to our meetings and give us some target. Yeah, go ahead, sir.
It seems to me that with more and more applications using CRDs, that's a very important piece of it. I guess that's level 3.
Yeah, the ability for each tenant to define their own CRDs.
Yeah, because I mean, you have application-specific CRDs in many cases now.
Well,
Like Kafka and stuff like that.
right. So the thing is that you can, depending on your operational model, you can allow your tenants to create their own CRDs even in the other models. It's just that there will be more coordination, right? In a namespace grouping model, you can say that a tenant can request a CRD and has to coordinate out of band with the cluster admin to get their CRD added at the global scope, right? So that's a kind of quote unquote poor man's way of doing it. But yes, if you want to do it in a fully automated and subservice manner, then that's the virtual clusters model, which is actually the least mature right now. So for the virtual clusters model, I think we are looking past 6 months from now.
Can I add something to that?
Yes, please.
One of the issues that we've had with multi-tenancy is because so few of these primitives have been in place up until now, people have sort of taken 1 or 2 quick looks at it and said, oh, no hierarchy namespaces, no self-service creation, no per tenant CRDs, I'm just going to do something else. The more of these barriers we break down, I think the greater a demand we are going to see for the remaining ones to be broken down as well. So while today there is not a great demand for namespaced CRDs, which is something that has been bandied about, I think that if that were the only thing that were sitting between a couple of large users and their multi-tenancy nirvana, you would very quickly see some movement on that.
An area that comes up often is quota management for tenants and possibly hierarchical quotas. So it's going to be a while before we get more on that.
Do we have time for one more?
Gentlemen, how much time do we have? Okay, maybe just the one more question, sorry.
You showed us 4 different models, right? But all your examples were defined on the first 3. The last model where you redefine the core and try to start from the tenant level, is there any work done on that, or that's totally?
No, our interactions with the SIG API server team so far have been, well, find me 20 developers that can do that and then we'll talk. So at the moment, that's not happening.
Okay.
So everything that's happening is on top of core Kubernetes. Now, HNC is an example of a project that actually could become part of core Kubernetes if there's sufficient traction. But at this point, everything is on top.
Yeah, we are trying to prove that there is a demand, a real demand for these kinds of features that cannot easily be satisfied using extensions, out-of-band communications. And so as I said, we've got a chicken and egg problem, so please come and join us on the meetings, use the stuff that we're building, and we'll start moving towards these more integrated solutions.
Where can we track this stuff again?
This is all available on GitHub. So if you go into, it's github.com/Kubernetes-SIG/multi-tenancy. Despite the name, we are not a SIG, we're a working group. But if you search for working group multi-tenancy, you'll find us pretty easily.
And I'll add these slides to this session, and the links are in the slides. But you can Google for us, working group multi-tenancy Kubernetes, and you'll hit the right links. That's all for today, but please reach out to us afterwards. And yeah.
Thank you.